let's suppose as an example that I wanted to solve the equation sine of 2x equals pi over 12. Oh, I'm sorry, that's not going to work. Negative 1/2. Needs to be a ratio, not an angle. Okay, so if I wanted to solve that equation right there, first thing I want to do is simplify this equation. And right now, this is not simple. When you solve equations, you want to be solving sine of an angle, not sine of some ugly thing. And so what I'm going to do is rewrite this equation by thinking of this as theta. So I'm going to do a little trick we've done in the past, which is I'm going to let theta equal to x. And that means now I have the equation sine of theta equals negative 1/2. So I've simplified the equation, which means now I can go to my unit circle and find all of the places where sine of theta would be negative 1/2. And is sine x or y? It's the y value. So I'm going to go look for the y value where it's equal to 1 or negative 1/2. So negative 1/2 will be in the bottom half. So I see that theta would be 7 pi over 6. And what is wrong with my answer? So do you see, though, that 7 pi over 6 is an angle where sine of theta would be negative 1/2? But the problem is my answer is not complete, because isn't there someplace else where theta is also going to give us a sine value of negative 1/2? Or, yes, so or 11 pi over 6. All right, so that's better, right? The answer is no. That is still not correct. Okay, and the reason for that is because couldn't I take an angle and rotate around like this? Okay, so then theta actually has many possibilities. It's any number 7 pi over 6 plus some multiple of 2 pi. And the way we say that is 2 pi times some number, and then and then 11 pi over 6 plus any multiple of 2 pi, and then we restrict k to be some integer, and z, this funny looking z, is the symbol for integer. Okay, so it's a z with 2 double lines is what it really is, so, or with double lines like that. Okay, so that means k is an integer, so it can't be fractions. I can't have like, I can't rotate 3/4 of a pi. I have to go full 2 pi rotations. There was no theta in the original equation, but there was x's, and I know that theta is 2x. So if I come down here, I can replace this theta with 2x. And how am I going to get x by itself? Divide by 2. Okay, so get x by itself by dividing by 2. When we divide by 2, then we're going to end up with x equals, and instead of 7 pi over 6, it'll be 7 pi over, so then instead of dividing by 6, I'll be dividing by 12. And the other way to think of that is, probably the easiest way to do this problem is to multiply both sides by 1/2. And then it gets distributed all the way through for both of them. So 7 pi over 12. And if I multiply 1/2 times 2 pi k, I would get pi times k. And then same thing down below. So 11 pi over 12 plus pi k. Once again, k has to be an integer. We have to keep that the same because we didn't do anything with k. So then this right here is actually all solutions to this equation. People are so used to solving an equation and getting an answer, or maybe two answers, like with quadratics or absolute value equations, or root equations. But exactly, you have an infinite number of solutions because sine and cosine are periodic. And so it's important to use that to your, or to remember that and put all of those pieces together when you find your solutions. So not only were there two possibilities on the unit circle that worked, we have to remember that there is an infinite number of angles that have the same result when you plug them into sine. The second one that we're going to do is going to look right away much harder, even though it's not. So let's start out. Let's suppose that I said that I had the equation 4 sine of x cosine of x minus 2 equals 0. Okay, so you're saying add this 2 to both sides. And then divide by 4. And so I'd have sine of x cosine of x equals 1/2. You're so close. Turns out that you guys just made this problem really hard to solve, but you were so close. So what you want to do is have your identity sheet out. And if you notice, this piece right here is really close to an identity. Okay. Well, that's why I want you to look at your identity list. So very similar to an identity. And which one is it? The double angle identity. Now, what number needs to show up though in front for it to be the double angle identity? A 2. So what we should probably do is either only divide by 2 here, or when we realize that we've gone too far, and you don't ever want to try to solve equations that have two different trig functions in them. It just becomes really messy. So the better thing to do is to try to rewrite that as a single trig function. So I'm going to go ahead and multiply this back by 2. And now I have 2 sine of x cosine of x equals 1. So that's a nice number over here. That's an easy one to solve with. And then right here, this is double angle identity. So we're going to replace that with what it's equal to. And according to the identity, what would this be equal to? Sine of 2x. So then I have the sine of 2x equals 1. And now this problem is very much like the problem we just did, except it works out faster because there's only one place where sine is equal to 1. And where is that? Pi over 2. Now I could actually do the trick that I did before where I said this is theta, or I can say, okay, I know that this is my angle. My angle had to be pi over 2. So that step I took where I replaced 2x or 4x or whatever with theta, you can do that in your head. You just have to make sure you do it correctly. And unfortunately, a lot of students don't do that correctly, which is why when I do examples, I very often will replace with theta, just to emphasize that that's what's happening there. But our angle that makes this equation true, our angle, here, I really need to emphasize this. The angle is pi over 2. Is that the only solution? No. What else can you do? There we go. So we have to add 2 pi k for k an integer. And then we can finish up this problem by dividing everything by 2. If you divide that by 2, that's the same as multiplying by half. So this would be pi over 4. Multiply that by half, so pi k. K an element of z. So a reminder that what we did here is we took both sides and we multiplied both sides by 1/2. And that gave us our x. And then this would end up being the angles that make this equation true. And you can check it by taking one of the angles or more than one. So let's start with pi over 4. If you plug in pi over 4, sine of pi over 4 is root 2 over 2. So you'd have 4 times root 2 over 2. Cosine of pi over 4 is root 2 over 2 minus 2. And the question is that equal to 0? And if I multiply this out, that would be 2 over 4 times 4. So the 4 is going to cancel with those, and I'll be left with a 2. So I'd have 2 minus 2, which is equal to 0.